Hi guys, we have Emma Gray here. She's going to talk about ecology and conservation of Julia Creek Dunnart. But before we start the talk, I would like to engage the traditional owners and the custodians of the land on which we meet. We pay our respects to their ancestors and their descendants to continue cultural and spiritual connections. We recognize their valuable contributions to Australia and global society.
Hi everyone. Thanks so much for the introduction and thanks so much for inviting me to speak today. We're sort of 1 and a little bit of years into a planned 3-year project looking at the detection, ecology and conservation of the Julia Creek Dunnart, Sminthopsis douglasi. So today I thought I'd tell you a little bit about our aims and methodology of the project and a bit about our results so far and also what our outcomes hope to be. But before I sort of dive into the project, I thought I'd give a bit of a background on Dunnarts. So Dunnarts are dasyurids or carnivorous marsupials that occur in the same family as the Tasmanian devil and quolls, but they're much smaller, weighing between about 8 and 70 grams. The genus occurs throughout Australia, but most species predominantly inhabit arid to semi-arid habitats. They're nocturnal and they're ferocious hunters of invertebrates, although they can also take down small reptiles and even other small mammals. They're even known to rip their heads off of house mice if they're unfortunate enough to be captured in the same pitfall trap together. And unlike Echinus, which I also did my PhD on and is another dasyurid, the male Dunnarts don't actually undergo a die-off after the breeding season, which is a nice change for me working on. And so the Julia Creek Dunnart was first described as a new species in 1979 by Archer, based on just 3 museum specimens. And then the species wasn't recorded for about another 20 years. And it wasn't until Pat Woolley enlisted the help of landholders in northwest Queensland that she rediscovered the species in catguts and owl pellets, and then subsequently trapped the first live individual in about 1992. And then Pat Woolley's student Greg Nissen then lived in the community for 4 years for his master's project, and he compiled some of the most comprehensive data on the species that we have now. And from this work, we know that the species is endemic to northwest Queensland, where they inhabit tufted grasslands dominated by Mitchell grasses and Flinders grasses on cracking clay soils. So the vegetation in this semi-arid landscape has really adapted, I guess, to survive extended droughts and also to exploit summer rains. And so during the dry season, the species shelters in soil cracks. And then during the wet season, as the cracks swell and close up and vegetation grows, the species likely shifts to sheltering within the grass tussocks. And then females are also capable of producing 2 litters over an extended breeding period. And this likely allows them to sort of spread the risk of failure and also to take advantage of conditions when they are good. And because of the species' restricted distribution, S. douglasi is currently listed as vulnerable federally and also endangered in Queensland. However, despite these listings, there really has only been sporadic research on the species since Greg's work finished in the early 2000s. And that's unfortunate because there's been, a devastating flood since then that sort of went through a lot of their habitat in 2019. So they haven't been monitored for quite a while. And that's why sort of the main aim of this study is to try to really understand more about the fundamental ecology of the species. And we're going to do this by sort of monitoring S. douglasi in at least 1 location over 4 years. So 3 years for this study, plus another year in 2022 that was a pilot study. And then also assessing the current sort of broad scale distribution of the species across northwest Queensland. So the monitoring portion of the project is currently being undertaken by Alice Backer, a master's student that's working at Bladensburg National Park, which is located just south of Winton. And Bladensburg was chosen because it's actually sort of the only protected area where we know the species still persists. And so she's been undertaking a marker capture study of the species using Elliott traps. So in total, every trip that she does, she undergoes 1,400 trap nights, which is 100 traps at 2 sites, open and checked for 7 nights. And it's sort of, every trap is set 15 metres apart in the grid pattern that you can see there. And she'll also be comparing the effectiveness of the Elliott trapping against white flash cameras and also thermal binoculars as well. And then the second part of the project is the distribution study. And this will be sort of what I'll mainly be focusing on. So I thought I'd first put up a map of where the species does occur, just to highlight a few key things. So on the map, the yellow points are the known records from ALA and WildNet previous to this research. The orange shaded areas are the regional ecosystems that we know the species is associated with or occupies. And the purple shaded areas are sort of the more potential tussock grassland vegetation groups that they could utilise. And so looking at the map, we can sort of see that there is a lot of likely and potential habitat for the species across northwest Queensland, but the species does appear to occur quite patchily. And so one of the main questions with the research is to try to answer whether the species does indeed occur patchily, and if it does, you know, why this might be, try to narrow down that a bit more. So is it because there just hasn't been enough survey effort done? This is valid, you know, a lot of northwest Queensland there is privately owned land that's used for cattle and sheep grazing, so access can be quite difficult. Is it that, yes, it looks broadly suitable, but are there microhabitat features that the species requires that we just sort of don't know about yet, such as, you know, vegetation associations or particular soil associations? Or perhaps there are threatening processes acting at certain intensities at certain locations, and perhaps that's more or less driving the species presence absence. But overall, with the distribution study, we're really just trying to get as many new dots on the map as possible for the species within the 3 years of the project. And yeah, that was my favourite souvenir from Julia Creek. I really quite like that one. It's nice when you have merchandise of your species that you're working on. But yeah, so with the study, in year 1 and 2, we plan to return to historic locations where the species has been reported before. And this is because, as I've said, it's been about 20 years since a lot of these locations have been surveyed, and there has been that flood that's gone through. So we really just want to see if they are still persisting in some of these areas. And then the next step in year 3, we plan to use a species distribution model to direct targeted surveys for the species in new habitat that might not have been surveyed before, but which the model indicates is highly suitable. And then so hopefully this will sort of answer a little bit about that patchiness question. How many new populations can we find and where are they? And I've just put like a text FDM up there just to show you what it will look like. But I'm currently working on a more comprehensive one in Maxent that'll only use vetted records and will account for spatial biases and things like that. And we'll also be using, a range of detection methods to try to find the species at these locations, including Elliott trapping, scent detection dogs, owl pellets and catguts, as well as hopefully using some eDNA air filters as well. And so I'll go into a little bit about each one of those methods. So the Elliott trapping was the method we used in 2023 in the first year of the project to try to find the species at existing locations. And it's currently sort of the most common method used to capture the species. However, trap success can be quite low, ranging from 0.05 up to about 4.3% trap success. And to illustrate this, Greg actually undertook 17,300 trap nights for his masters before finding a single individual. So poor Greg. It's also quite labour intensive as well. So generally when we go out, we put out 200 Elliott traps at a location, and they're each separated by 50 metres. So it's walking about 10 kilometres in the morning to check them, close them, and then another 10 kilometres in the afternoon to reset them again. So it is a bit of effort, and it does sort of limit the amount of sites that you can visit during survey deployment. However, in saying this, Elliott traps are still more effective than other direct capture techniques. So some of you might be sort of sitting there thinking, oh, Dunnarts, they're usually captured in pitfall traps. But the Julia Creek Dunnart is a little bit different and it can readily go into Elliott traps. It's not as trap shy. And Greg, again, for his honours, did a project where he trapped using Elliott traps and pitfall traps at the same site, and he was only finding the species in Elliott traps. So that's what we've continued with. Another kind of confounding factor, I guess, with live trapping methods is that there's two other species of Dunnart that can co-occur with the Julia Creek Dunnart. So there's S. macrura, the strap-faced Dunnart, and crassicordata, the fat-tailed Dunnart. And it's really important that when we're in the field, we can accurately identify the species. And thankfully, we can do this using sort of three main methods. So the first is body weight. So douglasi is actually the largest Dunnart species, weighing up to about 70 grams. So generally, when you have an individual, you can weigh it. And if it's over about 26 grams, you can be pretty confident that it's a douglasi. However, when S. douglasi are juveniles, they can overlap in size with S. macrura. So it's really important to check also the hindfoot length. Douglasi will generally always have a hindfoot length over 2 centimetres, even when they're a juvenile. They'll have a full facial strap, similar to the macrura. And they'll also sometimes, maybe not all the time, have some rufous colouring on the feet and also sort of in front of the ears. So they're quite colourful. And yeah, given, I guess, some of those limitations with live trapping, we're starting to train a scent detection dog to trial this method to find the species. And scent detection dogs are really being used more regularly in ecological studies to find those rare and elusive species. And my supervisor, Andrew, has actually used detection dogs in the past to detect 2 species of threatened antechinus species. And they've had quite good success with that. And they found that not only were the detection dogs faster than traditional Elliott and camera trapping, but they were also less labour intensive. And they were actually better at detecting the species, especially when they occurred in the environment at low density. However, again, there are challenges associated with using detection dogs. So one main issue, I guess, particularly out in northwest Queensland, is wild dog baiting. So a lot of the national parks and private landowners do bait for wild dogs, and that's also bad for our detection dogs. So we do have to really carefully plan field surveys. And unfortunately, that does mean that we do have to avoid some areas that have been heavily baited or that we're not sure how long that bait will sustain in the environment. Also, because S. douglasi is a small mammal and it likes to shelter in soil cracks, we do have a bit of an issue with corroborating positive detections in the field. So with other sort of species such as koala scat or perhaps finding birds or bats in wind farms, you kind of know when the dog's detected it's found what it's looking for. Whereas for douglasi, that might not be the case. So we'll be deploying camera traps and hopefully also the DNA air filters to try to corroborate the dog detections in the field. And access to target odor, non-target odor, sorry, has also been a little issue. So the Elliott traps are good at catching douglasi, but they're not so good for the other Dunnart species and also for planigales. So we've had to source some non-target odor from captive colonies, although because the captive animals sort of have a different diet, they may smell different. And so we have to sort of account for this in the dogs training as well. Owl pellets. And owl pellets, I think, are really an exciting method that we've been using to both detect the species and also monitor it. And it really is amazing the amount of valuable information you can find out from whole small mammal assemblages from owl pellets. And so, yeah, basically, generally an owl will typically roost in the same place for sometimes many years. And while the owl is roosting, they regurgitate the parts of their prey that they can't readily digest, such as the hair or bones. And then you can go through and find those pellets. And in Pacific grassland habitat, there's not actually a lot of sort of roosting areas for owls. So we found that pretty much most sheds that we've been into, we were finding an owl roost, which is great. And so this particular one, the abandoned shed on the top right there, we went into and we found hundreds of owl pellets. And we sort of teased a few apart in the field, and we found pretty quickly that there were S. douglasi jawbones in the pellets, based on the size of the jawbone and the size of the canine. So that was quite exciting. One thing about owl pellets is that you can't accurately date them, at least initially. However, once you sort of remove all the owl pellets from your area, you can leave, go relax, and then generally the owl will continue to roost at that location, and you can go back in 3 or 6 months' time, collect again, and then you'll know the date range when those pellets have been regurgitated. Catguts. So we're also collaborating with Southern Gulf NRM, who are managing feral cats at several properties with known Julia Creek Dunnart populations. And so based on sort of previous research, we know that when eruptions of boom and bust species start to increase in abundance, there's typically a corresponding increase in feral cat density, including in northwest Queensland, where the culprit is generally Arbulisismus, the longhead rat. And we think, well, we think that S. douglasi is sort of more threatened by this when the longhead rats actually start to decline, because once the rats decline, the cats will actually switch prey, often switch prey in other systems at least, to start predating on native small vertebrates. So in this study, we sort of aim to collect catguts during and after a longhead rat eruption. And then we'll use that to determine the frequency of occurrence of S. douglasi in the catguts, and also to try to determine whether this prey switching is occurring after the Arbulisismus decline. And the last method that we're hoping to utilise is eDNA air filters. And I won't go into this too much because we're still sort of in the planning phase for this one. However, we'll hopefully be using a design similar to Garrett et al. In that photo, which is basically filter paper housed in a special 3D printed case, which is then sort of connected to a computer fan, which then sort of filters the air through the filter paper. And so the idea with this study is to deploy the air filters to known habitat where S. douglasi are being monitored, for example at Bladensburg, or where the detection dogs indicate presence, at potential habitat where S. douglasi could occur, for example based on the habitat modelling of the SDM, and also habitat where we sort of are quite confident that S. douglasi don't occur. And this is to sort of act as a bit of a control just in case we run into contamination issues. And so, Yeah, so far with the technology, it's been used in sort of confined, semi-confined spaces. So a lot of the work's been done in zoo enclosures and also sort of captive bat colonies. So it'll be interesting to see how the eDNA air filter works in soil cracks in sort of a natural environment setting. And some results so far. So Alice has now completed 2 years of monitoring at Bladensburg National Park, and she's been able to consistently detect the species using Elliott traps. And she's also found that she was recording more individuals in 2023 compared to 2022 after some decent rainfall and when the vegetation sort of increased in cover. But yeah, I won't go into her results too much as she's currently writing up her master's thesis. And then I did 2 distribution surveys looking for the species. I found the species at Stanford using both Elliott traps and owl pellets, which was really exciting because the species hadn't been recorded since 1999 there. And it was actually a really high success rate of 4.6%, which is one of the highest for the species, including the capture of 15 individuals in just one night, which was really quite amazing. And then I went and did my second trip to Julia Creek, and we recorded no West douglasi. And that was because there was a rat eruption occurring at the time of our survey. And unfortunately, from 1,400 trap nights, we caught, I think, 1,020 rats. So well and truly ratted out from that trip. So I went from feeling quite confident, like I'm a good Dunnart catcher, to a less confident Dunnart catcher after that trip. But there was a silver lining in that we did detect the species using the owl pellets just outside Julia Creek. So I think that kind of really highlights the utility of using sort of multiple survey techniques when you're trying to find these elusive species. And I'd also recommend not using Elliott traps in a rat plague. And then, yeah, so we've still got a lot left to do on the project. So our next steps are we have 2 new honours students starting with us this semester, looking more closely at the owl pellets. So we'll have 1 student looking at owl pellets collected from 1 location over the wet and dry season. And then we'll have another student looking at owl pellets collected sort of across the distribution in northwest Queensland. We'll also hopefully have an advanced science student starting to look at the catguts when they start coming in. And yeah, the detection dog is still in training, and we hope to do our first sort of trial deployment in April, followed by 2 more targeted surveys this year, and then another 3 targeted surveys next year, looking at the new locations. We're also going to continue monitoring at Bladensburg National Park for another 2 years, to hopefully look at population dynamics as we sort of come back into an El Nino cycle. Although from the news, we may be going back into a La Nina, so we'll have to see how that works. And then, yeah, by the end of 2025, we'll hope to sort of collate our data on monitoring and distribution to sort of make some recommendations about the species conservation status, and also develop some survey guidelines for the species as well, for use by government agencies, but also private consultants as well. And yeah, I just wanted to acknowledge the financial support of Multicom Resources and Multicom and Epic Environmental for their development of this particular research offset program. And yeah, thanks to all our volunteers and helpers, also some from CBCS. So yeah, thank you.